Just coming.
Do you see that, Holly?
I see both your presentation and the poll.
Okay, good. Okay. So I'm assuming we can start whenever you want for that.
Great. Well, I see only about half of our participants have taken the poll, so let's give folks another minute or two to fill out the poll and we'll get going. All right, so I think we're at 70% of you have voted. If you haven't, please feel free to continue to fill out the poll. I'm going to leave it up for just another minute while I give a brief introduction to our training and then I'll close it down. So welcome to the intermediate group for the land cover and tree height training. It's great to see everybody today. There are several people here that I know. I wish we were meeting in person. It'd be fun to see you again. And several more people that I would love to meet in person. So thank you for voting. I wanted to get a sense of how many, or we wanted to get a sense of how many people have used the GLOBE Observer app before and how many people have used the protocols that we're talking about today before. And it looks like we have a mixed bag that some of you have done the tree height protocol, the GLOBE tree height protocol, and many of you have used the app, so it's about half and half there, and fewer people have done the biometry protocol, which is good to know. So I'm just going to go ahead and end that poll and share the results. Everybody can see it there. There you go. So that's really useful information. Thank you for sharing that with us. All right, so my name is Holly Cole. That's me, the distant picture there on the far left. I coordinate GLOBE Observer, and I am based out of NASA Goddard Space Flight Center, but I work remotely from New Mexico, from the southwestern United States, where skies are still quite hazy from all the wildfires out here. Brian.
Yeah, I'm Brian Campbell, and I am based at the NASA Wallops Flight Facility in Wallops Island, Virginia, in the United States. And I'm the NASA GLOBE Observer Tree Science Lead and the lead for the Trees Around the Globe student research campaign. And
should I introduce myself? Yeah.
Yes.
Hello. I am R.K. Garg. I am from Rajasthan, India. I am a master trainer for the GLOBE protocols, especially regarding biometry and tree height. And I work in a team. So thank you so much.
Great. You want to go to the next slide, Brian?
Yeah.
Thank you. So this is our session today. We'll spend a few minutes introducing you to the GLOBE Observer Land Cover and Trees protocols. They're slightly different than the protocols in the GLOBE program. Then we'll take a few minutes to go outside and use the GLOBE Observer app. So if you have not downloaded the app, I encourage you to do that now. Download and register. There will be a little bit of training that you'll have to take when you first open the app. So be good to go ahead and do that so that you're prepared to go do the practice session. So we'll give you a little bit of time, and while you're doing that, we'll stay on and be available to answer questions. And if you can't go outside, then it's okay to just take those observations inside without submitting them, just so you can practice using it. After that, we will have a little bit of Q&A discussion, and then we'll conclude by looking at the paper-based or the data entry traditional GLOBE protocols that complement the app version, and talk about how both are really critical and provide different information. Go ahead and go to the next one. So I'm going to start with an overview of GLOBE Observer. If you don't know, GLOBE Observer is a free app. It's available on Google Play or the Apple App Store, and allows volunteers from any GLOBE country to participate in GLOBE. So you don't have to be in a GLOBE school or participating under a trained GLOBE teacher. Anybody anywhere can participate in GLOBE with GLOBE Observer. Now, if you are a trained GLOBE teacher, as you saw earlier today, you can enter GLOBE data through Observer as well. The atmosphere portion of the data entry forms will be available on Observer later today or tomorrow, depending on which time zone you're in. So to use Observer, you download the app, you register for free using an active email address, and complete in-app training. So that's very simple. It doesn't require any equipment, so it's meant to be very accessible. You can use Observer offline. You will need a cellular or Wi-Fi internet connection to send data to GLOBE. And as I said, it is the app of the GLOBE program. Next slide. So today we're going to be talking about the land cover and trees protocol inside Observer. This is an overview of the land cover protocol. It is essentially taking a picture of a location, taking pictures north, south, east, west, up and down, and then telling us what you see there. This is very similar to the GLOBE site definition. It's essentially the same as the GLOBE site definition protocol, where you're at a location, you're identifying that location, and you're documenting that location with pictures. You also have the option to compare what you see. So you say that the land around you is grassland. You can compare that to the satellite data to assess if the satellite also classified that area as grassland. And there are lots of reasons it may be different, including scale, change since the satellite data product was produced, and other things. Right, go ahead and go to the next one. All right, so this is just a quick video giving you an overview of the land cover tool. All right. So as you saw there, the first step in the land cover protocol is taking the pictures facing north, south, east, west. This is a sample observation. And then the picture will be shown on the top of the app, and you tell us what you see in that picture. And these land cover types are aligned with the land cover types that you see in the GLOBE protocol. So it should be familiar to you. But if you have questions about it, you can type that little I button and get a definition of what that land cover type is. Each of them do have a drop-down menu, and you have subclasses within each one. And then once you select the land cover types you see in the photo, then we pop you over to just estimating the percent land cover. This is an estimate. We know it's not going to be as accurate as if you did the biometry protocol where you're pacing the pixel like you would do if you were doing that protocol, for those who have done that. It is an estimate, we know that, but it's just to give us a sense of what's there, just like you would if you were doing the site definition. Go ahead and go to the next. Okay, this is Brian, and I see a question in the chat really quick. Somebody asked Larissa asked if the video will be available to you to use after the meeting, and yes, it's already available now. It's on the Observer website. If you go to Do GLOBE Observer, it's under land cover, and it's there. It's also on the Observer website. We have a resource section for informal educators, and it's in that resource section as well. It's in the GLOBE YouTube channel, so it's in multiple places. You should be able to find it. If you have any trouble, please feel free to reach out. All right, Brian, all yours.
All right, thank you, Holly. So as all of you know, trees are part of land cover. That's why we wanted to start off with the land cover protocol as part of NASA GLOBE Observer, and then lead into trees, because when you're looking at land cover, most times you're doing that, unless you're in an area where there's no trees, you will see trees. So I wanted to start off by saying welcome to everyone, and and talk a little bit about why tree height's important, and then a little bit about the app. I'm going to show you a promo video like you just saw. And then, as Holly mentioned, after this, and then we'll give you some time to go outside and/or stick around. We'll be here to answer any questions or talk informally about anything you need to know about the land cover and trees tool. And then we will finish up with Dr. Gard talking about doing some comparisons with different observations with the protocols with NASA Go, and paper clinometer, and why that stuff's important, why tree circumference is important, things like that. So. A couple little things I like to show here, and some of you have seen my presentations before may have seen this, but I always like to give a little background. Why do we care about tree height? Why does NASA care? Why does why does anybody else care? Why should they care about tree height? So a couple things here. Tree height is the most widely used indicator of an ecosystem's ability to grow trees, and you can think of this in the terms of different areas, different biomes, different environments on the planet. You have areas that are very conducive to growing tall trees. If you look at the, out in, Sequoia, National Park, or you look at the Amazon rainforest, we see lots of tall trees there because we have the right, soil content, the right climate, the right amount of precipitation. But then if you look at conversely, if you look at the desert areas, not many trees growing there. We have with the sandy soil, we don't have a lot of precipitation. It's hot and dry and arid. So not the greatest thing. So where you see these areas where there's these tall trees growing, it's pretty much expected that this is a great ecosystem to grow trees. Tree height allows you to track the growth of trees over time. You know, many of you have, you know, your favorite trees that are around your home or in your community or someplace you've seen on your travels, you know. And for instance, we have trees outside of our house right now on equidistant on either side of our driveway. They're 2 crepe myrtle trees, and we planted those as saplings at the same time. They were about 2.5 to 3 feet tall when we planted them. Well, if you look right now at the tree height, at their tree height, one is about 16 feet tall and the other one is about 9 feet tall, even though we planted at the same time. Well, you know, I looked and I figured out why, because the tree that isn't growing as fast as the other one, the one that is shorter, sits in about 5 hours more shade from our home. So our home shades that tree for about 5 more hours during the day, so it's not getting that direct sunlight like the other tree is getting. So the photosynthesis, you know, process is, you know, the rate of it's a little different, and we're not getting as much of that sun's energy and, you know, the nutrients from the, you know, the soil might not be, you know, the soil there is basically ideal for both trees. It's just that sunlight is, the lack of sunlight thereof is affecting that one tree primarily. On the science side of things, and I see we have Dr. Eric Brown-de-Colson from NASA Goddard is here in the room here. It's a thank you for being here, Eric. But you know, on Eric's side of things, Eric does a lot with land cover and using you know, Landsat data and imagery and things like that. And you know, one of the things that, you know, he may be researching it, you know, during his career is that he's looking at the gain or loss of biomass of certain areas, and this helps us inform, you know, how much carbon trees and forests take in from the atmosphere, and they can store this carbon, you know, in these trees. Where you see these big tall trees with big branches and big trunks and you know, leaves everywhere, you know, that's an area where, you know, you can really look at that tree height. You can really you know, scientists can then figure out how much carbon is being pulled in and being stored or sequestered by those trees. And tree heights and just, you know, that perfect measurement to be able to try and do that. You know, it's a combination, I should say, tree height and tree circumference. But then we have at NASA, we have a bunch of missions. I mentioned Landsat. It was looking at, you know, looking at the landforms and looking how things are changing over time on our planet. Then we have missions like ICESat-2, Ice Cloud and Land Elevation Satellite 2, that uses an onboard laser altimeter to measure the height of trees and forest canopies around the world. We also have an instrument called JEDI, the Global Ecosystem Dynamics Investigation. It's an instrument on board the International Space Station that also, you know, is able to measure the height of forests around the world, you know, within a certain latitude, because it's actually flying differently than, you know, the International Space Station has its own orbit. ICESat-2 has its own orbit as well. So if they're hitting different spots, you know, there might be there's going to be some cross-reference things there, you know, where the beams, you know, overlap in their observations. But this is important for why, you know, why tree height is important, because it seems like such a simple measurement, and just by looking at a tree, you can tell that the tree is usually pretty healthy. If it has lots of leaves on it, if it's super tall, you know, you can figure out lots of things. And that's what we do with students with the Trees Around the Globe Student Research Campaign. We have them look at a tree, we have them measure a tree, and then figure out why the tree is either so healthy, why it's not healthy, and what in the environment is contributing to this, you know, potential, you know, tree height. And, you know, all these trees are part of that land cover. So with this, we have a couple things here, and I just have a couple screenshots here from the app that are super important that I wanted to discuss with you. When you go in and set up the trees tool, okay, when you go in after you register and you go into trees tool, as Holly mentioned earlier, you're going to have to do a little bit of training. And in the trees tool and land cover as well, there is the tutorial section and there's the introduction section. The first couple of boxes here, what you see, it says set up information. So what you have to do here is you have to put in what your estimated height is, and you can use the metric system or the English system, okay? You put in your height, so then the app then figures out or estimates where your eye level is, because that's what you're going to be using to measure the angle from your eye level to the base of the tree, and then your eye level to the top of the tree. You're going to keep it at that static eye level, okay? And then based upon whatever height you put in for yourself, it then estimates your stride. And I should mention that if you don't like that, I mean, we have We have some things on the NASA GLOBE Observer page, you know, some blogs and things like that that talks about how to estimate your stride if it doesn't happen to, if you don't think it is correct what the app is actually, you know, estimating, you can then go in and change that directly when you take an observation. And then also the last two boxes here that says, what do I do, and the tutorial. The what do I do just shows you the quick 4 general steps that you're going to need to use in order to do the tree height successfully. And then there's an optional measurement of tree circumference. We recommend you do this because this will help, you know, student researchers and professional researchers help to understand that whole carbon intake by the tree based on the size of that tree circumference, okay? And let me show you the intro here. This is just like you saw for land cover, but this is the tree height one. That should give you just a little, you know, little idea into, you know, what exactly you're able to do, and, you know, why we do it. So quickly, I'm not going to show this whole thing, but this is one thing I want to show you. It's just a quick screen grab I did when I was taking an observation. But I want to point out these 4 bullets over here, the 4 most important things to remember, okay? And only take NASA GO observations if it is safe and legal to do so. And we want you, after this, the trees talk that I'm giving right now, if you go outside, please do it safely if it's possible. You know, if it's possible to do a tree height observation and a land cover observation, make sure you do that safely, because we know that with the pandemic, there's lots of things going on in all these different countries that are part of this, part of the GLOBE program. When choosing a tree, make sure you can see the base and the top of the tree and be able to walk to its base in a straight line with no obstacles. Because what you're doing is you're counting your steps from your observation location to the base of the tree. And that's basically, you know, that's a straight line, okay? With that trigonometry involved with calculating tree height, we have to have that straight line. If you have an obstacle and you walk around it, your pacing is going to be different and your number of footsteps is going to be different, and you will get an incorrect tree height measurement. Always keep your cell phone's camera at eye level when measuring the angles to the base of the tree and the top of the tree. I mentioned that the app estimates what your height is, what the height of your eye level is based upon the height that you input into the introduction section of the trees tool. This is super important because all you want to do is you want to hold the phone at eye level, and then to the base of the tree, you're just going to tilt your hands and wrists down. You're not going to move your arms, because if you move your arms, you're like, if you drop your arms down to look at the base of the tree, or you lift your arms up to look at the top of the tree, it's going to give you the wrong number because you're changing that estimation of where your eye level is. So that's super important that you always keep your phone's camera at eye level when you're taking these measurements to the base of the tree and the top of the tree. And then always make sure you have your correct height for the current observer taking the tree at observation. What that means is, you know, if you're an educator and you have a couple devices in your classroom, or even with your families, you have to make sure that each time you have a different observer, you go into the introduction section, the little question mark down there, and you can change the height of the current observer. Because I'm 6'6" tall. My 14-year-old son is about 5'4". So if he goes and takes an observation and puts his height in, and we don't change it back to my height when it's my turn to take an observation, it's going to be incorrect. It's going to give an incorrect tree height because it won't have that estimated eye level correct again. So I hope that makes sense. So let me quickly show you that this is just about the last slide here, but I'm not going to run through this. I'm just going to show you this quickly because this is what you're going to see when you take a tree height observation on your screen. Okay, you know, if you're part of different GLOBE sites, this will come up. Not everybody will see this, but then it figures out what time and date, and then it asks for these service conditions, like you saw in the land cover video as well. So these were the service conditions when I took this measurement. I took this measurement just outside of the NASA Wallace Flight Facility. So then your camera opens up and you're gonna align this dotted line to the base of the tree, holding the phone at eye level. And then if you like that, you continue to the treetop. I'm gonna intentionally make a mistake here. See, I didn't get to the top of the tree, so I hit no, try again. And now I'm gonna try it again, and I got it. So I'm gonna do that. And then I'm gonna photograph the tree. And this picture that you see here is what's gonna show up in the GLOBE database on the Viz system. When you go in and look at the map, the global map, that's a picture that's going to show up. And then you can click on that picture and then basically see all the data related to what you just took, the observations you just took. So I'm going to speed this up here. So I'm walking to the tree, counting my steps. Then I did a tree circumference. And then you get to this super important box right now. And this is the review section. So it'll say your measurements. And then you have the camera height, which is what the app basically said your eye level is based upon your height, your estimated stride length based on your height, how many steps you said you took, and then the distance to the tree is then calculated based on your height and the number of steps. If, for instance, your stride would change, meaning if you have to walk uphill to the base of the tree or downhill base of the tree, your stride will change. So you can actually take a tape measure and measure the distance from the tree to where you were standing to take the observation. And then you can input that in here after just clicking the edit button, and then you will get a calculated tree height. You can see here, I just happened to, I'll click on the edit button, and I put in the circumference that was incorrect. I forgot to add the 0.5, here, it was actually 72.5, and I forgot to add that in. And then what's cool about this is in the comment section, you can put anything you'd like. If you know what type of tree it is, if you know, if you want to say something about the environment, or if the weather's doing something, or if it's windy or whatever, that's called metadata. You can add that to the comments section. So now, with all that said, I know we gave you a lot in about like 25 minutes or so, but we'd like you to head outside or even practice inside if it's possible. And we're going to take about 10 minutes for this because we want to be able to come in and talk more about this, and then we want to have Dr. Garg finish up with his part of the presentation after we do this. So I'm going to stop sharing now and come back to the main room, and please feel free to stay on, ask any questions you need. I can't see the chat right now because I'm sharing my screen and it's covering my entire laptop, but I'm going to unshare now and then come back. And then we're going to come back at, let's say, 10 minutes after the hour, or for Roop's purposes, it's going to be, I guess, 40 minutes after the hour because he's on the half hour. So I believe it's about 2 here. I guess it's around 11:30 there, maybe, right now in India. So let me go ahead and stop sharing, and feel free to go ahead and practice. And Holly, you have anything else to add to this, or Roop?
No, you did great, Brian. There is a question in the chat, and Jane, I'll let you go outside and practice, and let's make sure we bring this up when you get back in. Good question about choosing a tree.
Okay. So Holly, I still, or is Roller still on? I still see the poll one on my screen, and I don't want to mess with it too much because I just have back, relaunch, or share.
You can go ahead and close it on your screen.
All right, I can just say it back then, I guess.
Yeah.
Okay, got it. Okay, I just didn't want, I want to make sure nothing was gonna disappear that we didn't want to disappear.
Hey, Rich, can you unmute and we'll just chat about it? Let me see if I can unmute you.
Hi.
There you go.
Yeah. I'm not sure. I mean, I know which way is north and south in my yard. And I can take the pictures manually and does everything fine. I
Right.
have a compass, so I can figure out. I'm just wondering if there was a thing. And Roller said that there's an on-screen compass that appears, but it doesn't. So I don't know if I need to first install the compass
Yeah.
so that the observer app finds the compass.
So, yeah, I'm trying to remember how that works. What kind of phone do you have?
It's a Moto Android.
Let me just see. Some of them aren't 100% compatible with Observer because it doesn't integrate with the compass, which has been one of our one of the more challenging aspects of the app to keep functioning for everybody.
And it's a pretty new phone.
Yeah.
Anyway, it's a minor thing. So I used to not be able to take pictures at all with the Cloud app, and now I can at least do the pictures manually. So it's an improvement.
Yeah. I was just looking up Moto phones to see if it does have an embedded compass. I mean, even if you wait here.
Yeah, Holly, Roller said in the comments, he said the on-screen compass is part of the cloud. So is it transparent to anyone, or some people or something? I don't know.
Yeah, not the land cover protocol, unfortunately. I believe depending on which one you pick on the home screen of the app, you get different capabilities. So.
Okay.
I thought the compass function worked. I mean, I don't think they rebuilt it. I think that worked the same on both of them.
Yeah,
they use this code.
That's what I was thinking too. But I know for sure that it works in the cloud one.
Right.
So that's all I was saying.
Yeah. And I think what it is there may be it's either a permissions issue in your phone, like you just haven't given the observer permission, or you don't have, let's see if I can get it to work. I mean, you're going to see just my hand here, but can you see my screen?
Oh, yeah.
So you should be seeing that, as you rotate the directions popping up there. And I don't know if it's a permission thing or if your phone just simply doesn't have the magnetometer, because not all do. And that's what we're using to get direction. Mm-hmm. In that case, I mean, it should work on most phones. In that case, in case it doesn't, you don't see it, you can take the pictures manually and just use an external compass. You could try, the other thing to check when we're troubleshooting is if you open up a Maps app, Google Maps or whatever,
Right.
Do you get your direction in there? Does it tell you you're facing north?
Direction. Well,
Or
I don't know that it does. I mean, I guess I haven't noticed that. I just noticed the map, and I can drop the pin, but let's see, where would it?
So on mine, when I open it, I get a little, I don't know, I can't tell what you can see. I get a little compass button. It doesn't tell me which direction. It just kind of orients, but it just tells me that there's and then if I asked for directions, it might indicate, let me just see what else you can look at. But that's another place to just check and make sure your phone has the capability.
Okay. Yeah, I am seeing a compass little thing.
Okay.
There.
In that case, it may be a permissions thing.
Mm-hmm.
And what would give you access to the compass? I mean, usually you just have to give it your permission to access your location when you're using the app. We don't ask any other time. Mm-hmm. But it should just tap into that. I'm not really sure what's going on there. Yeah, I'd be happy to, well,
Oh, I can just play around with permissions.
yeah.
I have a pretty
feel
new
free to-
phone, so I need to get in and look through this stuff anyway. So, okay,
Doris, no worries about it being, yeah,
okay.
those,
Thank you very much. That's helpful.
of course, Rich. And if you're having any other problems as you play around with it, there is a contact us at the bottom. There's like a question, or well, there's a contact us form. Anyway, and if you click on that, the question actually now goes to Roller, and we can troubleshoot with him and us and Dave Overroy just to see if we can work out exactly what's going on.
Right.
Yeah.
We can figure out if it's the phone itself or what. Maybe it's reinstalling the app. Reinstalling the app sometimes.
Right. So those of you who are indoors because it's night, just feel free to give it a try inside, and just to get a sense of how it works. We wanted you to try it yourself, so we can show you, all day long how it works, but until you do it yourself, I think you'll get a much better sense of what's going on and maybe where you might have questions.
Looks like it's 11 past the hour, Holly.
All right, so is it time? You said 10 after?
Yeah, I think it'll be good because Roop has some things to cover, and then it'll be done by past the hour or top of the hour for Roop.
So we have a few minutes for questions. Did any other questions come up while you were doing your observations? You can put them in the chat, or feel free to unmute and just chat or just talk. We're a fairly small group.
And Jane, are you still there? I don't see. Oh yeah, she's
okay.
Janet, not Jane. Janet. Yeah. Right.
Do we screen the images? Yeah. Just go ahead and put your question in the chat if you can't unmute. Do we screen the images to make sure they're all trees? Yes, we do. We look at all the photos that come in and verify that they are what they say they are, that they don't have a person in them. Any photo that has a recognizable person is not entered into the database. We want to protect people's privacy. And if it has text like a car license plate or something like that might also compromise somebody's privacy, we also do not put those in the database. Okay. Yeah.
Let's say I wanted to measure the light pole just for fun. I wouldn't be able to keep that data in any way. Like, let's say I was just trying to get used to the app and I wanted to measure like a stump or the flowers in front of the house or.
Yeah, that we don't delete. It's just there because it's the photo itself that doesn't get deleted, or that gets deleted. The data still goes into the database.
Okay,
so if it's a building or something, we're going to keep it just so that when you as a scientist go back to use the data, you can look at that photo and say, oh, wait a minute, this isn't just a tree, or this isn't a tree, this is something else, and I should be aware that it's something else.
Next time I run into Brian, I'm going to measure him with the app to see if he's really 6'6".
I think I was 6'7" at one point, but I think I shrunk. But everybody says I'm taller now. But I don't know. Yeah.
I'm finally unmuted.
Okay. All right. Thank you, Janet. Yeah. Let me go to your question here. I'm gonna go back to it. Yeah. So, great question. Looking at, if you're talking about the rainforest areas and places like that. So, a good rule of thumb is first you have to be able to see the base of the tree and the top of the tree and be able to safely walk to the base of the tree in a straight line. Okay. And as I mentioned, it doesn't have to be, it can be uphill or downhill. And that's just the whole stride thing that you may have to change. And then you also mentioned in your question about, shorter trees versus taller trees. And all are fine. And let me explain to you why that is. You know, if you're able to see it, you know, yes, you know, if we're going to do comparisons to like ICET2 or like JEDI, sometimes if the canopy, the upper canopy is very thick, you know, some of those lasers, those photons won't penetrate down through and get the shorter trees. But your measurements are something that the satellite cannot get, and that's why it's even more vital, you know, because we'll have that data from your end of things. Now, one other thing I want to mention is that, you know, ICET2 is, you know, about 300 miles above the Earth's surface as it's flying. It's flying like a near polar orbit. So when these photons get sent, these laser photons get sent out of the satellite, it spreads out. The photon spreads out.
Yeah.
And by the time it hits the ground, it's about a 13 to 14 meter diameter photon footprint. Okay. So what's happening there is that when ICET2 returns a tree height observation, that number that's being returned is the average height of all the trees within that 13 to 14 diameter footprint. Now, if you go out and take multiple observations, and here's an example of what I did. I took multiple observations, and you can also, I have a poster session as part of this, this week's events, and that poster session talks about the comparisons between ICET2 and the GLOBE data. But if you go out and take observations of as many trees as possible, you know, in that area, in that densely packed area, and then you can then compare it to what ICET2 saw. If you happen to be in an area where you see, you know, we use a tool called Open Altimetry, and you can see that on the poster. It's openaltimetry.org, and I'll put that in the chat then. But ICET2 can actually measure individual trees as well. It's rare because of the large footprint, but I've actually seen ones. Actually, one in my neighborhood ICET2 measured a Bradford pear tree that was sitting next to a pond. So just in that footprint, yeah, it's invasive. Well, it's half gone because the tropical storm Isaias ripped half of it apart last August. So half of it's still there. But with that said, you know, we'd like for, you know, take as many observations as you can in that densely packed area, because those areas are super important for scientists, because those, what we call that data density. Mm-hmm. And with ICET2, we tried to get data density, meaning a lot of measurements in a smaller area. You know, so if you have that densely packed area, if you have the ICET2 data and you have as many trees that you can measure as possible, you know, in that area, the better. You know, and go out, you know, frequently, you know, you can go out every week or every month, every couple months, and just, you know, measure those changes that you may be able to see, or that you might not be able to see with the naked eye if it grows like a meter or so, or half a meter. You know, taking those observations really helps you understand how fast that tree is growing or how slow it's growing. So that rule of thumb, yep.
One quick follow-up. I just want to be clear too about part of my question is, I get that I need to see the bottom of the tree and the top of the tree, but especially in that when we're down in the emergent canopy, if I'm measuring the big tree and there's a little tree in between it, as long as I move the camera to get the top of the tree I'm trying to get and the bottom of the tree I'm trying to get, it's going to be fine, right? Yes, because it's like doing a linear measurement.
Right. Yeah. Because that's what you're doing. You're holding it. You're holding it right at eye level, and you're just doing this. Mm-hmm. And yeah, and just as if you just, you know, if it's that you're right. It's that linear measurement. You're just make sure that you get the top of that tree, the exact one you just got the base of. Yeah.
And do you know if there are any people doing specific tree density work in Peru, or is there somebody that we could talk to? Because there's a group of us, excuse me, with the Morpho Institute that have a teacher workshop every summer, and one of our projects for this summer coming up would be to measure some density and then carbon dioxide fluxes and, you know, all the things attached to that. So we'd have like a week where we could take some pretty incredible samples over, you know, inland and right on the river and all sorts of stuff. So
I think
who can we connect?
Dr. Nayera Pinto at JPL is doing some work in South American rainforest area, and I just don't remember which country. Okay. But she might be a good person to talk to, just because she's already working in that ecosystem. Eric, you may know other people.
Pinto,
Brian.
Pinto, P-I-N-T-O.
P-I-N-T-O.
Janet, I'm going to put in the chat, and he said it's okay to do this, Peter Falcon's email address, because he works with Dr. Pinto at JPL, and you can contact him because he's part of our Trees Around the Globe campaign, and he works with Dr. Pinto. So I'll put that in there, and you can ask about that as well.
Perfect.
I mean, there may be some researchers associated with Brian's mission, ISAT-2, and there's that JEDI, GDI. I don't know that they're doing specific work in South America, but they're trying to evaluate their products. So I'm sure any kind of information would be useful. And I'm sure Brian can get in touch. The question I had for you, Brian, and I can't remember, I mean, it's sort of related to what Janet was asking. I mean, most of the time, if you go in a dense forest, it's usually not flat. And so does the app, so if like the tree you're looking at is on a slope above you, let's say, can you still do the base and the top of the tree and get a height, or is that a problem?
No, you can still do it, but that's where it comes into, you get that weird thing happening with your stride, because if you're, you can, the angles will be okay, but you get that stride because if you're walking up a hill, a lot of people, some people tend to, their steps get closer together and their stride changes.
Right.
And try to get up that steep hill. But yeah, we haven't had any issue with that. We've tested that out. I know Dave Overall and his team tested it out in California with being trees on slopes, being you're above the tree or they're below the tree. So, and they've worked that into it, but it's just a matter of the stride.
That's good.
And that's true of the dense vegetation as well, right? If you're walking in somewhere that's densely vegetated, your stride is not going to be normal. So it might be better to bring a tape measure in those cases. And fix the stride length, Abraham. Yes, you would. You have
spiny brush.
To fix that. Right, you want to step around that. Brian, I know we're out of time for questions, but there was one last one that you can answer very quickly in here that I think Claudia asked. What is the shortest kind of tree you can take a measurement of?
So so
5 meters. Yes.
Go ahead. Sorry about. I was talking. Sorry, Holly.
I said 5 meters, but I'm not sure. So go for it.
Yeah, that's about the standard, because that's what's in the original tree height observation for the GLOBE biometry protocol. So yeah, about 5 meters. I mean, but we've taken and tested out ones that are a little shorter than that. That's just kind of the standard that we wanted to put in there, because that's been part of GLOBE for a while. Now it's like that gold standard. So yeah, about that 5 meters or so. All right. So let's pass it over to Dr. Garg. Are you ready for that? All right.
Yes. Hello.
All right. Let me go share my screen. Let me share my screen.
Yeah, please.
Garg, and,
please do so.
Yeah.
We have discussed a lot more things about the measuring of the tree height and how to use the app, which is available very easily. But at the same time, we need to understand the different aspects of the ecosystem. And at the same time, many observations that are made through the app and the observation which are made by a personal person through other methodology, there should be an accuracy of both of them. That is point number one. Another very important thing is that this is GLOBE is a program for school students where they learn not only science, but the mathematics and other technology also. So in order to understand the mathematical aspects, some local observations by a traditional method for measuring the tree height is equally important. So we will talk about the tree height measurement and the measurement of the tree circumference by traditional method. Next, please. Yeah, next slide. So we all know that, the last one. Hello, previous one. Hello? Yeah. We are interested, why we are interested to understand the vegetation, how it is disturbed, how dense the forest is, does the sunlight penetrate the forest floor? As someone was asking that if there is a rainforest, what will happen? Is the landscape dominated by grasses? So all these questions we have to answer. And then there is a muck classification for the measurement of the this this that is a modified UNESCO classification. So this is the book which we use for the muck classification. But maybe that for that we have to go to a homogeneous mass of the area. Then you have this homogeneous mass must be at least 90 meter by 90 meter. And you have to sample 30 meter by 30 meter in order to understand the muck classification in our study. Next, please. Yeah, next slide. Yeah. So we want to have the accuracy of the measurements and precision of the measurements. And for that, we have to not only observe the tree height and the circumferences, but by human being also, as well as by the app which we are using. Next, please. So, next, why scientists need a biometry? Because they want to document the characteristics of the vegetation of different sites, maybe a forest area, maybe a grassland, maybe a scrubland, maybe it is a open forest, or it is a closed forest, or it is a rainforest, or it is a desert area, or describe the distribution pattern of the vegetation, whether there are more shrubs, there are more trees, there is a floor on which there is a vegetation. And so we have to answer these questions. Another thing is why there is an impact on the land cover. It is weather, it is water chemistry, it is soil properties, or it is all of the above. So naturally the answer will be all of the above. Next, please. So we do measure the circumference of a tree at our breast height. We use a very simple kind of this tap, which is a flexible tap, and in which we can measure the at the breast height. Because whenever as Brian was saying that his height is higher than his son's height, so a person who is an observer, he has to put his both the hands around the tree in such a way that neither he has to lean down nor the person has to just put their arms upwards. And that's why whenever we generally take the observations of the this circumference, we use it as at the tree height. So in general, it is 1.35 meters. So it is an important biometry protocol to understand the local ecosystem as well as the storage of the carbon in the forest ecosystem. Next, please. So from tree height, one can understand many measurements, especially the forest people, the scientists, and the timber growers, that what amount of standing timber is present in a particular forest. As well as we can understand the climate change, the carbon dioxide fixation by the trees, and understand how much carbon is stored in the standing vegetation at a particular area. And this gives us, if we have the observations for many years, we can understand is there any climate change effect is going on or not. Next, please. So for that one, for measuring the tree height, generally by human being, we use this kind of instrument. This is a clinometer. It is a very simple kind of, device in which there is a hypsometer, and then we have a thread on it, and then we are hanging a small weight, maybe a visor or something like that, and then we use a very simple this drinking straw. This drinking straw, from this drinking straw we see from one eye, and then you have to stand at the same level of the tree, and then we see the angle. And towards the other side, once the angle is measured, on the other side of this, we have the tan value of that angle. And from that, we can calculate very easily the height of a tree. Now, if we take, we stand at such a distance from the tree that our angle, this angle is 45 degree, then the tan value will be only 1. So it is very easy to calculate the tree height. Next, please. Now this instrument is called actually the clinometer. Yeah. So this is a small film. We need a straw, string, tap. Yeah. This is how to make the clinometer. You need a string. You put the string at a designated place. Then just make a note so that it may not fall down. Put a very small weight, or maybe a visor, or maybe something like that. Then we put a straw on the designated place. Fix it with the help of a cellophane tap or adhesive tap. And on the other side of the same paper, so this is all we need: straw, string, tape, scissors, pencils, washer, clipboard, etc. And then one can very easily prepare a small kind of clinometer. Next, please. Now, this clinometer is held in the hand in such a way that we see the tree top, the last point of the tree. And your angle in general, you remain standing at such a distance from the tree that your angle should be somewhere between the 30 to 60. Preferably it should be 45, but if it is not possible, then you stand at such a distance that it should be in between 30 and 60. Now you have two kind of observations: the tree height observations with the help of a handheld paper clinometer, and another is the observation of the tree height with the help of the NASA GLOBE Observer. Now you have to compare both the data, and then you may have the data from the satellite. So you can compare all the three data, and then you can find out the tree height. In general, in a sample area means is area which is 30 meter by 30 meter, we should try to take the observations of a dominant species, of a co-dominant species, as well as the species which are very less in the number. so that we can have a correct picture of that particular ecosystem. Next, please. So this is all I want to say, and this kind of observations are very important so that the students can learn about the science, about the mathematics, about the technology, as well as their actual observation and hands-on activity can go on. Thank you so much. If there are any questions.
I see a question from Ibrahim. Is it necessary to use a clinometer? You don't have to do. The reason we included that is, originally in the GLOBE program, the biometry protocol contains 4 different ways to measure tree height, and that's using a clinometer, and that was prior to the NASA GLOBE Observer. What we wanted to highlight here is that you can compare the tree height. Say you want to take a tree height observation, you can take it with the NASA GLOBE Observer, and then you can also take it with a clinometer and a handheld clinometer, and you can do comparisons. And this will help you with your accuracy of taking tree height observations using both methods. So it's not required that you use a clinometer. It's an example of an activity that we have that is part of the NASA GLOBE Observer, where you can, better increase your accuracy of measuring tree heights by doing comparisons between the two. And yeah, Eric, we have done it, and we've gotten pretty good success with it. And it's difficult. We've actually had some students that are thinking about potentially doing some research projects related to that, doing comparisons between the two. But, I've gotten some great results, and, other folks at GLOBE have as well.
Actually, what I feel is that if there are student research these projects, in that case, they can take both kind of observations, and then they can compare the data, and actually they can find out if there is a difference, and these observations they can correlate in their research projects.
And Marcia, your question, I think we'll finish up with that question, Marcia, because of the time. We're at 37 past the hour here, and I know it's probably tomorrow for you by now, Dr. Karg. So yeah, the question there is a clinometer considered the most accurate? And I'm going to answer with that it can be, because in order to use a clinometer well, you have to practice it. I know a lot of students have they practice it because they don't understand the whole how to hold the clinometer correctly and all that. I mean, there's also there's digital clinometers. There's plastic ones that you can hold up to that has a line of sight. So there's all different type of clinometers. The paper one isn't the easiest to use, but it's very good at helping people with students and even educators, focus on how to take those ground-based, hands-on observations. So the clinometer can be extremely accurate, and the app is extremely accurate as well. So that's why we have that activity there, so you can do a comparison between those two different methods of measuring tree height.
Now, another thing which I want to share is that in many developing countries, the students from the rural areas, they do not have the access to the very good kind of the what you call a this mobile app. So in that area, the clinometer is very important, and they can measure it very easily.
Right. I just want to say thank you, everyone, for being here, and this will conclude our training session. And feel free to contact us, directly anytime. You've seen in the chat, you had some of the emails. Hopefully, you grabbed some of those down. Yeah, thank you so much for joining.
Okay, all the best, and thank you so much.
Thank you.
Roller, will you just end it then? Is that just how it's going to go?
Yep, I got the power. I'll click.
All right.
Okay.
Thank you, Roller, for everything.
Thank
You're welcome.
you.
Thank you, thank
Have a
you,
good day.
thank you, thank you, everybody.